My name is Linda Lunny. Until I retired 18 months ago, I worked in the Dictionary of Irish Biography, which is a project of the Royal Irish Academy. Kathleen Lonsdale got one of the over 9,000 biographies that we wrote for that publication. Along with a colleague, Enda Leaney, I worked on her life. Why should we remember Kathleen Lonsdale? Why is this prize named in her honour? And why, more generally, should we remember her in Ireland? She hadn't the best start in life, at least to outward appearances. She was born in 1903, the youngest of 10 children, in Newbridge, County Kildare. Her father was an Englishman who was the town postmaster, but he had a drink problem. And when Kathleen was only a small girl, her mother separated from her father and took her family of 10 children to England. 4 of the children died in infancy, but Kathleen made a great success of her education. She got the top county scholarship to go to high school, and when she was 16, she was able to go to attend Bedford College for Women in London. The Nobel Prize-winning crystallographer W.H. Bragg was the external examiner on Kathleen's outstanding final degree exams, and he was so impressed by the diminutive and very determined young woman that there and then he asked her to join his group in University College London to study the crystals of organic compounds. She developed novel techniques and insights, and she was able to confirm the structure of the benzene ring, which was something that had puzzled scientists, including Bragg, for more than 60 years. Another major contribution was her compilation of essential reference tables for X-ray crystallography. So, we should remember Lonsdale for more than her contributions to chemistry, acknowledging her importance as a role model for women. And she was someone who made practical recommendations on the changes to society that would make it possible for more women to work in science and industry. And still, that isn't all. In 1935, she and her unusually supportive husband, Thomas Lonsdale, became members of the Society of Friends, and as Quakers, they opposed war. But Kathleen Lonsdale refused to register for war work, and thus was sentenced to a month in Holloway Prison. Her experiences of the dire conditions led her to become a campaigner for prison reform. Later, she also became internationally known as a leader in movements opposing nuclear testing and armaments. And to finish with, something to think about. A quotation from Lonsdale herself, which is at least as relevant today to young and to old scientists, at least as relevant as it was in the 1950s. I believe in good, not just as a hypothesis, but as absolutely fundamental to all my way of life. A scientist should take interest in national and international affairs, not as a politician, but in making sure that facts are properly known and trying to ensure that science is used for good and not for evil purposes.
The Corja, especially until of Padre Gagaira, Uachtaran Acadif Riagan Aherin, agus is more than Nordum, Falcha Korov Galer, Godia Acadif in you. So I'm Pat Garian, President of the Irish Academy, and it's a great pleasure to welcome you all to the 2024 Kathleen Lonsdale Royal Irish Academy Chemistry PhD ceremony. This is always one of the nicest days, I have to say, in the Academy. It's always nice when there's a celebration and someone gets an award. Everybody seems to have smiley faces, so that's a very important event. We, as academics, we sit at many various meetings and many things where actually nobody smiles at all. So it's actually nice to be here on an occasion where I can look. Almost everybody looking up is smiling. Sorry, the photographer is not. He's busy doing his photography work. So at the beginning of the ceremony today, I feel it appropriate to take a moment to acknowledge the incredible personal and professional achievements of Kathleen Lonsdale, which you've just heard about, for whom this chemistry prize was named. Like several in this room, I'm the leader of a research group, and as it turns out, with many talented early career researchers, we are here today to recognise one such person, Dr. Billy McCarthy. Congratulations, Billy, and to award him this prestigious prize for his PhD thesis, Understanding the Entry, Partition and Fate of Chlorates in Dairy Processes. So as someone who grew up in a dairy farm in South Tipperary, who spent most of my formative years, I have to say, milking cows and feeding calves, I'll be interested to read your PhD thesis and see where all that goes. So I look forward to getting a copy at some stage and reading that. So a warm welcome to Dr. McCarthy's PhD supervisors, colleagues, friends and family. So you're all very welcome. And indeed, welcome to Academy House. You may well have passed by Dawson Street many occasions and peered through the windows and never really knows what goes on in here. Don't worry, a lot of the people who come here don't know what goes on in here either. So I'm really trying to overcome that in many ways. But it's not just opposite Café on Seine, which is where I always give people directions as to how to get here. But it's a really important national institution. So we're the Learned Society for STEM, science, and also the arts, humanities and social sciences. So we're joined here by Dr. Hugh Fay, also of Henkel Ireland. Good to see you again, Hugh. Henkel's generous sponsorship of this award is vital in enabling us to recognise excellence in early career research in chemistry, and we're indeed very grateful for your continuing sponsorship. This prize is awarded by the Royal Irish Academy every year to the most outstanding Irish PhD thesis in the general area of the chemical sciences. It aims to inspire confidence in young researchers, rewarding their ambition and confirming their place in international chemistry research. The prize is named for and awarded in the spirit of Irish X-ray crystallographer Kathleen Lonsdale, who you've just heard about, and she was a brilliant researcher from the beginning, publishing her first major contribution to crystallography at 21. You would have heard about the fact that how her work was fundamental to determining the structure of benzene, but of course it wasn't the X-ray crystal structure of benzene she determined at all, because benzene's a liquid, and you can't get an X-ray crystal structure of a liquid, but you can of a solid. And hexamethylbenzene, which is just a derivative of benzene, is indeed a solid. And I lecture first year organic chemistry in UCD, and I always bring up that as an example. And I always see if there's anyone there from Kildare, or at least any Lillywhite, willing to put up their names. And I always make a big point of the fact that she was born in Newbridge and, you know, as you heard, then left to go to the UK. So that's the benzene story out of the way. And it's something that puzzled people for a long time, because nobody had any real idea about the shape and the fact that it was planar, what type of hybridization was involved. And we have a whole Kikuli story about a snake catching its tail. So there's a whole background to that, which I won't bore you with anymore. But there you go. Organic chemists like to talk about organic chemistry, and that's life. As a scientist and a thoughtful and fearless, female leader, she engaged with the world in ways which still prove inspirational today. The announcement of the winner each year is timed to coincide with Lonsdale's birthday in January. Every February, the winner of the Kathleen Lonsdale Royal Irish Academy Chemistry Prize is nominated by the Academy to be Ireland's entry to the prestigious International Union of Pure and Applied Chemistry Solvay International Award for Young Chemists. This is a highly competitive international prize, and the IUPAC, which is the abbreviation for that very long named society, has members from over 60 countries, and winners of the international award are selected from a large volume of nominations. The quality of applications for the Kathleen Lonsdale Prize this year was again outstanding. We will hear from a member of the judging panel, Dr. Neva O'Boyle, about the judging process and the impressive range of projects. However, first we'll hear a bit of an update from last year's winner, Dr. Chun-Chin Lee, who was supervised by Professor Stephen Bell, who's also a member of the Royal Irish Academy and indeed Vice President for Research in the Academy as of March 16th this year.
Hi everyone, I'm Chun-Chun Lee, the recipient of the Kathleen Lonsdale Prize 2023. I completed my PhD at QUB with Professor Stephen Bell. Right now, I'm an associate professor at the University of Shanghai for Science and Technology. Surface chemistry is particularly important for nanomaterials, which derive their unique properties from their large surface-to-volume ratio. So figuring out ways to observe and manipulate nanosurfaces is the golden ticket to pushing nanotech forward. To this end, my PhD research was focused on designing plasmonic nanomaterials that manipulate light at a nanoscale to enhance the Raman signals of chemical species near the nanosurface. This technique, known as SIRS, can be used to probe metal-molecule interactions in situ with molecular specificity and single-molecule sensitivity. Using SIRS, I studied a series of important surface chemistry problems during my PhD. Most notably, this led to the observation of strong pi-metal interactions in colloidal nanoparticles that have been neglected for decades, which is significant to a variety of applications in sustainability and healthcare. Before I wrap up, please let me extend my congratulations to this year's winner, Dr. McCarthy. I vividly recall the thrill and honor of receiving this prize. This prize is more than just a recognition. To me, it has been a cherished milestone and continuous motivation that boosted my academic career. I'm sure it will do the same for you. Finally, I would like to take this opportunity to thank again the RIA and Henkel for such an amazing experience. Thank you all for listening.
So thank you to Dr. Lee for contributing that video, taking the time to tell us about her award-winning research and the impact of winning the Kathleen Lonsdale Prize last year. I'd now like to thank the expert judging panel of the Kathleen Lonsdale Prize for their commitment and expertise in the always difficult task of selecting a winner. The prize judges were Professor Sylvia Draper, Professor of Inorganic Chemistry at Trinity College Dublin, Dr. Niamh O'Boyle, who we'll hear from later, Assistant Professor in Pharmaceutical Chemistry in Trinity College Dublin, Dr. John O'Donoghue, the Royal Society of Chemistry Education Coordinator in the School of Chemistry at Trinity College Dublin, and Professor Peter Robertson, Professor of Chemical Engineering at Queen's University in Belfast. I now invite Dr. Niamh O'Boyle to say a few words about this year's competition and indeed about our winner. Niamh, over to you.
Hi, good afternoon, everyone. My name is Niamh O'Boyle. Thank you for the kind introduction. And I'm an Associate Professor of Pharmaceutical Chemistry at Trinity College Dublin. I'm also a proud Lily White. And yes, I was tempted. I grew up actually by coincidence just across the road in the house that Kathleen Lonsdale was born in. So this makes me particularly delighted to have been a judge for the 2024 Kathleen Lonsdale Prize. This prize recognises the best Irish PhD thesis in the general area of chemical sciences, which is very broadly defined. And it's judged by three things. The first is an applicant essay. The second is a publication list from the PhD. And then finally, there are 2 letters of support. The Academy's Young Chemists Award was first awarded in 2020. So this is the 25th year of the prize, making you the 25th winner. This year, we received applications from right across the island of Ireland, and the areas were incredibly diverse. So, for example, there was a thesis on Martian soil, rechargeable batteries, and then medicinal compounds as 3 examples. As always, as Pat referred to, the standard of applications was extremely high, and the applications were a real showcase of the rigorous and impactful research being carried out by researchers on this island. It also, the diversity that we saw really reflects how broadly the chemical sciences can be applied. So it's all those different areas. So as the judging panel, it's a tough job, but our role is it's twofold. So first, we assess the quality of the PhD thesis itself, and also, very importantly, the candidate's ability to communicate that in a condensed and accessible format. So after this year's assessment process was carried out by a 5-member panel, we agreed to award the 2024 prize to Dr. Billy McCarthy from Technological University Dublin for his thesis, Understanding the Entry, Partition and Fate of Chlorates in Dairy Processes. So just a few words about the thesis. Dr. McCarthy's very impressive PhD thesis addresses the factors affecting chlorate contamination in dairy products, and proposes, importantly, an innovative new method for chlorate management. So using a process called membrane filtration, Dr. McCarthy succeeded in developing an industrially feasible approach to chlorate removal from milk, something that probably will affect us all in the future. And in doing so, he has tackled a significant food safety challenge faced by the dairy industry. In particular, the assessment panel for the 2024 Kathleen Lonsdale Prize were impressed by the clarity with which Dr. McCarthy set out the parameters and aims of his PhD research in his application essay. He had 2 very strong letters of support from his PhD supervisors, and they particularly highlighted his passion for collaborative research and his interest in science communication. I think as a reflection of that, Dr. McCarthy published 5 peer-reviewed papers as the first author, And together with 11 conference presentations, I can agree that's very impressive, delivered as a result of his PhD thesis, he clearly has gone above and beyond in both his research and his desire to disseminate it. This is a very important piece of research, I believe, that is likely to have a significant impact on the Irish dairy sector. Dr McCarthy, who is now working full-time at Teagasc Moorepark Food Research Centre for a short while longer, is evidently a skilled and conscientious researcher who's motivated by a desire to harness chemistry to really tackle real-world problems. Earlier in the year, we were delighted to nominate Dr McCarthy as Ireland's entry to the annual UPAC Solvay Young Chemist Prize, as Pat also referred to. And today we are so proud to be awarding you the 2024 Kathleen Lonsdale RIA Chemistry Prize. So congratulations to Billy.
Thank you, Dee, for sharing those thoughts and remarks, and we're very grateful indeed to all the judges for their expertise and input in assessing the Kathleen Lonsdale Prize this year. So I'd now like to introduce Dr. Hugh Fay from our sponsor Henkel. Dr. Fay has been a supporter of the Kathleen Lonsdale Royal Irish Academy Prize for the past 8 years. Time flies. The continuing support of Henkel has allowed us to champion early career chemistry research in Ireland and internationally. Hugh, over to you.
Thank you so much, Pat, and hello everybody. The agenda for today was with military precision. There were things that are 3 minutes long. For me, it said Hugh will give a short speech, which I guess my hour and a half last year was a bit ill-judged. Sorry about it. This will be short, honestly. And I will be repeating myself partly because it's a different audience. But just to tell you, I'm from Henkel, and we have 90 people in research and development in Tala working on adhesives and sealants. And 90 people, 45% of those have PhDs, and that's across the board. So study and research at PhD level is really important to us. So just to let you know how we get the funding is that we've got to apply to a corporate jury, and they judge. They are in charge of giving out money to things like this throughout the world, not just many events like this. And we, so far 8 years in a row, or certainly the last 7 of the 8, have had no problem getting because it's recognized as being really, really good. I've got to say a word of congratulations. But you have lots of parents here. You have academic parents knocking around. I think 2, it seems to have at least 3, which is certainly there's 2 academic parents really proud. You have 2 real parents there behind you. I say, congratulations, folks. Like, this is a huge deal. This really is a shining star in Billy's CV that'll last him his whole life. So, congratulations to you for your input in different ways, bringing him to GA training and stuff, or whatever you did when he was a child. And Billy, I just say 2 things to you. Enjoy it. I know it's, look where you are, but there's not many days people are saying nice things about you. Happens when you're born and when you die, and maybe if you get married. But other than that, this is a precious day. And I want to say genuinely congratulations. I only read the summary of your thesis. It sounds brilliant. It obviously has a fantastic level of academic input, but also has a fantastic level of applicability. You can read that. You're probably one of the few people I see who could talk to somebody about their PhD work outside of chemistry. I certainly couldn't talk my one to anybody, never mind someone outside. So, Billy, congratulations. It's a great day. And from behalf of Henkel, we're really proud to be involved in this event. Congrats.
Thanks very much, Hugh. And just in case you don't understand just how important a PhD is in the Fay household, Hugh's daughter Ellen is right now giving her Institute of Chemistry of Ireland Research Award presentation at the Research Colloquium down at Trinity College Dublin. So congratulations to Ellen. And I've had to miss this to be here, as they say, but at 2:15 we have to go down and present prizes. So congratulations to her. So could I ask now Niamh, please, and Hugh to step forward again. And I would now to invite Dr. O'Boyle to present the prize certificate and Dr. Fay to present the prize envelope. Very important. There's something in the envelope.
Oh, thank you. Yeah, it's been very humbling to hear all the nice things said about me. It's thank you so much. No, this is an honor. Kathleen Lonsdale was an amazing scientist and role model in person. So it's honestly so humbling to be here and be recognized today. So I'm just going to give a quick talk through my PhD thesis, which is Understanding the Entry, Fate and Partition of Chlorates in Dairy Processes, which I did with TU Dublin and Teagasc Moorepark. under the Walsh Scholarship program. So my academic career, just a summary, started off in UCC doing a bachelor degree in Chemistry of Pharmaceutical Compounds, and then moved on to Teagasc, where I wanted to do an industry-focused project on where I could get real-world application where I work. During this time, I got more involved in science communication, including PubHD Cork. And following my PhD, I decided to do a postdoctoral fellowship in functional and nutrifunctional properties of beta-lactoglobulin variants in Teagasc again, to continue my work there in food science. So just an introduction to chlorates. So chlorine compounds are widely used in clean-in-place protocols. So they're typically used in food processing and pharmaceuticals to make sure there's no bacteriological contamination or physical contamination. So the formation of chlorinated residues is raised concern with food regulatory bodies. So these being triolomethanes in butter and chlorates. So chlorate is formed as a byproduct when using chlorine dioxide hypochlorite, which is primarily used in the chemical disinfection step. But because of hypochlorite's use in water treatment, it can affect the entire CIP cycle. Chlorate was first discovered in Stuttgart in 2013 in on the German agricultural produce market, where it was in about 22% of produce there. In 2023, specifically in milk, it was detected in approximately half the Irish milk, cream, and yogurt samples by Martin Danaher up in Teagasc Ashtown. Chlorate is primarily issued because of two factors. First is thyroid toxicity. Iodine is taken in by the thyroid to make thyroid hormones. Chlorate can actually go into the thyroid instead of iodine and inhibit this synthesis, which can lead to issues with neurological development and cognitive development. So in the blood as well. Okay, so it can oxidize the iron center of the red blood cell from the iron 2 to iron 3 oxidation state. So blood is essential as allows oxygen to be carried around the body. However, in the presence of chlorate, this can be oxidized. Oxygen can no longer bind, and cells, tissues, and organs are starved of oxygen. So this can lead to something called blue baby syndrome. So within water, there's a maximum residual level of 250 micrograms per liter, are set within the European Union, but worldwide this is 700 micrograms per liter. And initially in food for chlorate, because it's a pesticide, it was initially established as 10 micrograms per liter, but then since it's been revised to 100. So how does chlorate enter the dairy supply chain? So as mentioned before, it's primarily through chlorinated water, but also through the cleaning of farm and processing equipment using chlorine products like hypochlorite. So chlorate is particularly concerned to the infant milk formula companies due to its adverse health effects, which babies are more prone to. And this has led to a removal of chlorine detergents at a farm level and all the way through dairy processing, but chlorine contamination still persists, as mentioned before. So the first part of the PhD was to put together all the literature on the topic from soil, environmental, pharmaceutical, and other food areas to put together a document for the dairy industry so that they could have a reference document and know exactly how this affects them and what they can do to avoid it. Upon designing the project, it was first noted that chlorate goes with the skim milk side, so it's not fat soluble. So I decided to focus on three main areas. Firstly, how chlorate behaves during heat treatment. Secondly, how it would behave during membrane filtration. And finally, spray drying and evaporation. So first, with the Fate of Chlorates in raw and pasteurized milk, we found that there was no real impact of heating the milk. But what we did find is that over time, depending on if it was pasteurized or incubated or raw, that it would break down differently. So the raw milk actually started to break down after about a week. So upon doing more investigation, it was noted that microbial reduction could be responsible. And what was interesting is that this was not actually noted in milk before, but had been noted in water and soil. So I'm not going to get into the isolation steps as they were tedious, but I managed to isolate out 5 different strains, which were all capable of reducing chlorate, but none of them had genes associated with perchlorate reduction. But upon growing them again in chlorate-rich media, they all seem to be able to grow, so they're able to metabolize the chlorate, but the mechanism is still not known, or it's still being investigated at the moment. Yeah, so this was actually published in microbiology, but also a new Walsh Scholarship was funded to look into this further, into the genomic and the metagenomic instances and what's happening here. So next was the use of nanofiltration to remove chloride from milk. So, so upon starting the project, there was no documented means of removing chlorate once present in milk, which was a major issue for the dairy industry, as any contaminated product had to be sent to waste. And upon looking at this and looking at the possible options out there, membrane technology was one that I highlighted due to its wide use in the dairy industry already and no need for new infrastructure or training on the topic. So within dairy, there are two primarily used ones, so nanofiltration, reverse osmosis. Reverse osmosis would concentrate up, or was found to concentrate up the chlorate, so it wasn't a suitable process, so we focus on nanofiltration. So using membranes, we were able to remove 60% of the chlorate in milk on a dry matter basis. And this was something that hadn't been done before. We also looked at how the different minerals in milk are also affected, as if we were able to remove all the minerals from milk, it wouldn't be a useful process. But chlorate actually separated out at a faster rate than everything else. So it was actually suitable in dairy processing. So this was published in the International Dairy Journal, and because of Teagasc's link to industry and to stakeholders, this has been implemented across Irish dairy sites to remediate out of specification products, and as a critical control step for dairy coming in. Finally, I looked at the contribution of municipal water to chloride contamination during skim milk and powder production. So there are 5 stages to traditional dairy processing, so equipment operation. So at first you put water on the system, just to get everything up to temperature and make sure it works efficiently. Secondly, you transition from your water to your skim milk or your whatever product you're going to process. Then you go into steady step operation, which is where you produce your product. Finally, you change from your milk to your water again as part of a cleaning step, and then you run on water finally, just to system flush and before cleaning. So I decided to focus on these 2 steps. So from there, I did this in the Moorepark Technology Limited, which is our industry scale plant in Teagasc Moorepark. So I got pasteurized milk, put it through an evaporator, spray dryer to produce skim milk, and I did this in 2 different conditions. So one being with just municipal water, so water from the tap. So it's treated with chlorine, so it would have chlorine in it, so chlorate could be there. Secondly, I looked at reverse osmosis, which is pure water, which would not have chlorate possible as a control. So what I found is that when evaporation, so we actually found that initially there was a chlorate level much higher than that was present in the milk. And we put that towards at the start of evaporation, it's like a kettle. So the water level gets lower, you're running it constantly. And the chlorate in the water actually concentrated up before putting the product in, which led to an initial high spike in chlorate levels. Alternatively, with the reverse osmosis water operation, we did not see this. So it was highlighted as a best process for industry. So, and also that batching of milk concentrate prior to spray drying could mitigate it. So collecting large amounts before bringing it over. Then then I looked at spray drying on our 5,000 liter spray dryer in MTL, and found that, like in the evaporator, the start and the finish, so the transition onto the product and transition back onto water, were the instances where there was highest chloride contamination, and this was because of the water coming into contact with the milk, forming a particle, and the chlorate being part of that particle then. So it was then, so from this, there was a publication, and through interaction with stakeholders, this has become best practice on many dairy sites, particularly those who are in water catchment areas with known high chloride levels. From this, it was possible to help industry deal with this issue. So just some conclusions from this. So bacterial strains capable of chloride reduction have been isolated from milk, and they're being further investigated by a new Walsh scholar in Teagasc Moorepark. Yeah. So membrane processing, which was widely available and readily used in the dairy industry, indicated as a chlorate removal method from milk, which could deal with out-of-specification product. The use of our water during equilibration spray drying could reduce chloride contamination in final powders, which is particularly important for infant formula, where everything we put through a spray dryer. So that is pretty much my talk today. I'd like to thank my supervisors, so Professor John Tobin, who can't be here today, Professor Christine O'Connor from TUD, Dr. Tom O'Callaghan, Dr. Martin Danaher, Dr. David Gleeson, my friends and colleagues and family as well, particularly my parents who get a special shout out. But and finally, I'd like to thank the RIA and Henkel for this honor. It's been a fantastic achievement, and I'm truly honored that you recognize my work with this award. No, thank you so much.
So thanks to Dr McCarthy for his fascinating presentation. And you might have grown up across the road from where Kathleen Lonsdale lives, but actually my neighbour across the road is the son of Professor Walsh, who's the Walsh Scholarships. So who said Ireland's a small place, huh? So it's a pleasure to learn more about your project. Well done, and indeed your research career so far, and we wish you all the very best for the future. So congratulations again to you, and thank you to our members and guests, judges and sponsor for joining us here today to celebrate the Royal Irish Academy Prize awardee, Dr. Bill McCarthy. And indeed, we now invite you in a time-honoured fashion to join us for even more refreshments in the council room at the back. So, Gorf Míle Maith Galéir agus Banacliff. Thank you.